This is Cosmographia, the Randall Carlson Podcast.
Well, we'll lay that out. Look, Let's just lay that out. Okay, well, we recorded episode 20 on January 13th. We're trying to jump back in the timeline here.
Right.
There might be a little bit of overlay. You know, it's been a month and a half since we recorded. We're trying to pick it back up.
Yeah.
All right.
So, geez, we're over a month and a half older now than we were then.
On episode 20, yeah, man.
Yeah.
I think that, it's starting to show. I was wondering why you guys.
Yeah, I got gray hairs. You
You didn't have that
I've been stressed
on
out.
January 13th.
I'm not as shiny as I used to be.
Right. There's
You
some
are
shine
less
that's been
shiny,
lost.
Cal.
Yeah, what happened to you guys? You're not shiny.
I'm getting dull.
Yeah.
It's been a month and a half.
It's March in Texas.
Yeah.
Whatever that
Yeah, we
means.
ought to just leave that in. Welcome back, ladies and gentlemen, to the Kosmographia podcast. You just heard us talking about how long it's been since we recorded. So we had this problem where all of our episodes were being published. I don't know, what was it, Brad? Like maybe 2 or 3 weeks, 4 weeks? Like we were 4 weeks behind? How far back?
We were way behind. Well, I got a distraction for 6 weeks at the end of the year, so that threw me way off some family obligations. So yeah, I was at least 6 weeks behind at one point.
Right. Well, but it's also because we started recording episodes long before we were ready to publish anything. So we already had a bunch in the hopper by the time we got the feeds up and the channels ready.
We did.
So we had been behind this whole time, and we were trying to catch up, and it just wasn't working. So we decided to stop recording new episodes until Kyle with the audio and Brad with the video could catch up. And that has happened. Episode 20 was the last one we recorded, and that was on, what was it, January 13th?
Yes.
Right.
And it just got posted.
It just got
last
posted.
couple days of February.
Right. So now we were recording. This is episode 21. So we haven't recorded an episode for a month and a half, and we're all like Randall is saying, we're all much older, and it's showing.
We're much wiser now.
Yes, we're much wiser and maybe a little bit less shiny.
I think I got the same gray hairs.
But in episode 20, which most of you just watched or listened to, we were talking about the critics of the YDB of the Comet Research Group. We were going through the papers of Surovell et al. With George Howard. We went through the papers of Scott et al. The criticisms of the Younger Dryas impact hypothesis, and then on episode 20, we were going through Lecomte's response to Surovell's paper. We went into the details of that. And Randall, I wanted to ask, because this was interesting to me as I was going back through the episode trying to prepare for today's episode, and I'm listening to this, and I'm thinking, okay, we're talking about Surovell in his paper claims, well, first, Boslough says that Surovell followed the Firestone et al. What do you call it? Protocols.
Protocols, yeah.
Right. So the protocols say, okay, your sample size needs to be of a certain thickness, like 2.3 centimeters, which is less than an inch. And then from that, you need to use this specific sized sieve. And it was, I don't know what that was, 250 millimeters or something like that, microns, yeah. So, and then you need to use, the electron scanning microscope, right?
Mm-hmm.
And they didn't do any of those right. Surovell got a sample thickness that was almost a foot thick instead of less than an inch. And then he used a sieve that was way bigger than what they put in their protocols. And then he used the wrong, instruments to look at it. He didn't use electron microscope. And so I'm just wondering, like, can we really say that's incompetence? Because that's like saying, okay, if you're telling somebody you're working on building a house and you're like, I need to go get me a 2x4 and cut it 2 foot 4 inches, using the table saw. And the guy shows up with a 1x6 that's 6 feet long that he cut with a hacksaw. That's not incompetence. There's something else happening there. You see what I mean? So I just wanted to have a quick rant about that because I can understand them getting one of the parts of the protocols wrong, but so many parts of the protocols they just completely fail to do correctly.
Well, and the one thing I didn't mention was a lot of the samples weren't even from the same place. The Firestone team took their samples. So there's that too. But, I don't know. To be fair to those guys, here's the thing. It's so precise that the precision we're talking about here, that layer it's very tiny. So, the methods that they may have been used to, that they've been working to find samples of, let's say, more macroscopic material just aren't suitable. And, whether it was incompetence or I don't think it was a conspiracy.
Right. It does. It sounds like gross negligence to me. Like they just completely failed to actually look at the protocols and follow them. Right.
That's kind of what it appears to be.
I think they didn't want to find what they were supposed to be looking for.
Right.
They weren't trying to find it. They were trying to miss it.
Yeah. That's a conspiracy.
Brad's on the conspiracy side with us.
They wanted to not find it, and so they used the wrong protocols and then claimed that they used the right protocols. That's my problem here. Now, I know we can't look into the guy's head and say what were they trying to do, but we're saying let's give them the benefit of the doubt. Well, that's a huge benefit to take that they made that many mistakes. It seems like they didn't even try to look at what the protocol actually was.
Mm-hmm.
I don't know. It's hard for me to believe that somebody who's an accredited scientist can get that many things wrong, and have it be actually a mistake rather than intentional.
Mm-hmm.
Well, what's most frustrating is that's the story that got picked up and spread around.
Yes.
Somebody that did that work that was incomplete, incompetent, if you want to call it that, but that's the story that got put out and people read and believed.
Right.
And think that's the end of it. I don't have to pay attention to this. That's the end of it.
Yes.
Proven wrong. So, and like we said, it's like the stories were already written.
Yes. Right.
Because we read through one of them and it said, this paper released earlier today. It's
Right.
like, okay, well, did you get it at 6 a.m. and wrote your article by 8 a.m. or, they were ready for it. They were like Mike said, it was PR.
Right.
They were prepared to put out that story with that angle.
Yeah. Mike gave a great explanation of what he thought was going on in the journalism world there. And he ended up saying that number one, it was laziness on the journalist's part, plus the establishment guys have much better PR. So all the journalists knew that the paper was going to be released. So that's how they had the articles written already. So that, by 8 o'clock that night, they had an article out for a paper that was released earlier that afternoon or whatever.
I'm going to agree with you, Mike, on the bad PR on the part of Firestone et al.
Yeah.
But I'm on the conspiracy side of the journalist issue. I think they're also in there.
Yeah.
Yeah, let's throw this thing under the bus.
But we're not doing a conspiracy show.
Hey,
yeah.
You can go check out our podcast.
Right. Come to Brothers of the Serpent podcast if you want a conspiracy.
There you go.
We'll talk about conspiracies.
We're
the
trying
whole
to
day.
stick to the science here.
You guys need to invite me on the podcast.
Yeah. We'll
All
get Mike on
right.
the podcast. That would be great.
Absolutely.
Yeah.
Wednesday night.
Okay.
So what, Mike's going to go in there and debunk all the conspiracy theories?
Yeah. He can come on there and explain to us the journalism world, and we can try to convince him that it's all a giant conspiracy, and he can try to tell us how it's not. That'd be great material. It'd be a fantastic show.
I'll get flamed.
No, our listeners are cool, man. The Snake Force is great.
The snake force. I like it.
Yeah.
That's
yeah.
right.
You got T-shirts saying snake force?
No, but we
Coming
need
soon.
Coming
Should.
soon. I got my hat on, Brothers of the Serpent hat.
Yeah, but it doesn't say
representing.
snake force. You need to.
No, it doesn't,
You need to
yeah.
say snake force across the band in the back.
Yeah. So where are we going today, Randall?
Well, there's so much material out there that's now accumulating, relevant either directly or indirectly to the whole controversy, that it's tricky to decide exactly where to go. I'm going to maybe jump back a little bit in time, try to fill in some gaps that
All right.
what I'm actually working on, which will be available to all the listeners soon, is I'm doing a timeline. I'm putting out all of the relevant information as into discoveries, the pro, the con, the pro, the publications, then the responses, going back actually to pre-2007, because a lot of the stuff, focusing in on the Younger Dryas goes back to the 1980s and 1990s. And it's a very interesting progression to see how, as the dating gets refined and as more knowledge is attained about the Younger Dryas, that the researchers and workers on that are perplexed by the suddenness of it, the severity of it, what could have been the causal mechanism. So you see a lot of that going on in the decade leading up to the 2007 Firestone paper. I find that stuff to be extremely interesting, personally. I don't remember, without having reviewed, how much exactly we've talked about that. But, we can go back to, even the 60s, where a lot of the impact proxies were first being identified. Hexagonal diamonds, for example, when they were discovered in the Behringer, in the proximity of Behringer Crater, which is Meteor Crater, also called the Canyon Diablo Crater. It's got different names, but it's the most famous one out there, just east of Winslow, Arizona.
Those are the Lonsdaleite. Is that
Lonsdaleite? Yes.
So we
exactly.
did talk quite a bit about Lonsdaleite. I don't remember it being connected to Meteor Crater, though. That would be interesting to hear.
Yeah. Well, that was one of the places that it was found. So that was one of the first connections between Lonsdaleite and a high energy, hypervelocity impact event. And then it was around that time in the 60s where it was first synthesized in the laboratory as well. And then, let's see, I can pull something up here. Let's see, our results. Let's see, polymorph carbon, hexagonal diamond. Another, the Goalpara meteorite. You might look this up, Kyle, while we're going on here. This would be Goalpara, one of the meteorites in which Lonsdaleite was found. Yes, this phase has been synthesized recently under specific high pressure conditions in the laboratory. So I'm reading actually from something that goes back to 1967. And then the DYALPUR meteorite, small, fine-grained black agglomerates, a few tenths of 1 millimeter in size.
But what was that second meteorite called, Randall?
It was the DYAL maybe.
Okay, DYAL.
PUR. Yeah, so these were two meteorites in which this particular diagnostic of high pressure impacts was found. And this is going back to the 1960s. So, you had the series of discoveries that were actually leading up to the Younger Dryas impact idea, which of course was not introduced until 2007. And then, there was, P.A. Paul Mayuski, hopefully I'm pronouncing his name somewhat properly, who did work in the early 90s on atmospheric conditions during the Younger Dryas. And by the time he was writing, he was able to say that one of the most dramatic climate change events observed in marine and ice core records is the Younger Dryas, a return to near glacial conditions that punctuated the last deglaciation. High resolution, continuous glaciochemical. So this is taking chemical analysis of deposits within ice sheets. When you say glaciochemical, so there's glacier, right? High resolution continuous glaciochemical records newly retrieved from central Greenland record the chemical composition of the Arctic atmosphere at the time of the Younger Dryas. The record shows that both the onset and the termination of the Younger Dryas occurred within 10 to 20 years, and that massive, frequent, and short-term, meaning less than a decade, changes in atmospheric composition occurred throughout this event. The magnitude and complexity, in other words, these massive decade or less fluctuations in atmospheric chemistry of the soluble species record documented in the Younger Dryas portion of the ice of the JISP-2 core provides evidence of an extremely dynamic atmosphere thus far unparalleled in the Holocene. So you can see where they're getting to. Now, I mean, they're looking at this period and going, something really bizarre happened here. We got to get to the bottom of what it is. Now, of course, in the models that the critics, I guess to the extent that you can call them models, are putting forth, these kind of changes that could be documented not only in temperature changes, atmospheric compositional changes, collapse of the megafauna, rapid melting of the ice sheets, deposition of the impact proxies, disappearance of the Clovis, they're all basically independent things that happened with no direct relationship to each other at all. Whereas the idea of the Younger Dryas impact really is a coherent theory that sort of ties all of this together and can provide a causal explanation. But of course, being an extraordinary hypothesis, I'll use that word rather than theory, because at this point it's still a hypothesis. In the immortal words of Carl Sagan, extraordinary claims require extraordinary proofs. So we're 13 years in now to the Younger Dryas impact hypothesis since it was first showed up in the peer-reviewed scientific literature. If you want to find it earlier than that, you can go back to a series of lectures I did in 1996 where I didn't call it the Younger Dryas impact hypothesis, but I'm talking about potentially an impact being the trigger for the Younger Dryas boundary event and also for the cause of the megafaunal mass extinction. Anyways, once we come forward, go ahead. Yeah.
This may take us a little bit off topic, but is anybody looking at the end of the Younger Dryas? Because I know most of this Comet Research Group stuff is they're looking at the beginning, right?
Right.
That's where they're looking for impact proxies and so on and so forth. But there were the same kinds of violent changes at the end of the Younger Dryas. So is anybody checking those layers?
Oh yeah, yeah, yes.
Okay.
And even as we speak, so as we get more time to devote to this, which we are, we will be able to draw on a lot more current and topical information.
Okay.
So yes, there is some very interesting stuff on the Younger Dryas pre-boreal transition, which is the considered to be a transition from Pleistocene to Holocene at 11,600 years ago. So, then so in 2008, we had a flurry of things. What we're seeing is kind of pulses of new research coming out. We talked about Vance Haynes, the elder archaeologist, highly respected archaeologist that was also an expert on the Boslough Younger Dryas boundary that has always, within recent years dated to about 12,900. And we did the quote, where he said that stratigraphically and chronologically, the extinction of the megafauna appears to have been catastrophic, seemingly too sudden and extensive for either human predation or climate change to have been the primary cause. And human predation, we have discussed that considerably, although there's a lot more to look at there. The relationship between humans and the megafauna, the relation between the humans and the events that terminated the Pleistocene and led into the Younger Dryas. And then climate change. Certainly climate change was a factor, but the question becomes, what do we look at as an agency for driving that climate change? Because the climate changes were on such a scale that typical things that we experience today are not going to do that. They're not going to cause temperature changes over, say, the North Atlantic of 8 to 10 degrees centigrade, say, in less than a decade. So we have to find what kind of an agency, something is, prompting these kinds of changes. And, the thing is that the critics of the Younger Dryas impact hypothesis don't have anything to offer in exchange for, well, we're going to try to say that there was no possibility of an impact. Well, then what?
Right.
Then what? Yeah.
What's the mechanism then? If it's not an impact, if you guys want to debunk that, well, then tell us what the mechanism was.
Right.
Yeah. Replace it with something. And
he says that what he refers to the Rancho La Brean, which is basically just a catch-all term for species of megafauna that existed from roughly the Younger Dryas back to a couple of 100,000 years ago. It gets its name from the La Brea tar pits, where so many of the different species of late Pleistocene megafauna were found out there in LA. So that's all. It's just when you're talking about Rancho La Brean, you're just talking about those megafaunal species that were existing at the end of the last ice age, say from 13,000 years ago up to 100,000 years ago. I don't know the exact date at which it's going to that it's going to begin, but it's somewhere around that. So the sudden Rancho La Brean termination at 10,900 plus or minus 50 BP. And when he's talking here 10,900, that is radiocarbon years that have not been calibrated yet. Calibration primarily based upon tree ring records, because with tree rings, you can count the individual layers. And there's a whole dendrochronological timepiece, if you will, that has been developed going back into the latter phases, the upper Pleistocene strata, where if you have a tree that you can count backwards, and if you got a 300-year-old tree and you can count the rings back to 300 years, then you have another tree that, for example, existed from 500 years ago to 250 years ago. They're overlapping, see? So what they've done is painstakingly correlated those overlaps, and they've now been able to push the dendrochronological record back to just about 13,000 years, interestingly. And now what you do is you take the radiocarbon ages of those trees and you correlate those with radiocarbon ages taken from many other samples, right? And so what has happened is over thousands and thousands of these measurements, they're able to correlate back into the later stages of the ice age, and they're using that to calibrate. So what they can actually count in terms of calendar years has offset from the radiocarbon years by 2 millennium by the time we get back to the ice age. So when you say 10,900 radiocarbon years, you got to add 2,000 years to that, basically, to get calendar years.
And that implies that there was, at some point, a large influx of carbon-14 into these older objects, because otherwise they wouldn't date younger.
Right.
Which is interesting, because that's cosmogenic. Those are cosmogenically generated, right? C14
Yes.
Yeah.
And that is something we need to explore too, because
Right.
What was going on cosmogenically during that time. Because again, as we get into looking at the details, it gets fascinatingly complex. He concludes his 2008 article on the Younger Dryas black mats and the Rancho La Brea termination in North America with this comment: recent evidence for extraterrestrial impact, although not yet compelling, needs further testing because a remarkable major perturbation occurred at 10,900 BP before present that needs to be explained. So here's distinguished professor of archaeology who's looking at this and realizing that blaming it on, whatever happened, there was this, he referred to it as a perturbation. This perturbation was very all-encompassing. And he's saying, yeah, obviously there's something here we don't know. Something's going on that we don't know. So yeah, we looked at imagery showing some of the black mat layers. And did we talk about the Montana evidence? I don't think we did we?
I don't think
I don't think so.
That's not ringing any bells, because that was some of the early stuff too. This was actually a paper that was presented at the American Geophysical Union spring meeting in May of the year 2008. D.W. Baker, P.J. Miranda, and K.E. Gibbs were the authors of the study. And the title of their paper is Montana Evidence for Extraterrestrial Impact Event That Caused Ice Age Mammal Die-Off. Evidence has been found in Montana for an extraterrestrial impact event previously documented in the states of Arizona, New Mexico, North Carolina, and South Carolina, and in Alberta and Manitoba. A mammal fossil site dated at 11.5 Ka, carbon 14 before present, was described in 1969 as the last mammoth occurrence in Montana. Now, bear in mind that dating goes back to 1969. The mammoth remains were found in an organic-rich layer of black mat. The black mat contains abundant charcoal, and in parentheses, evidence for forest fire, black carbon glass foam, plant material deposited in a pond, and unrusted iron micro-meteorites. Scanning electron microscopy, photos of iron micrometeorites reveal fusion crusts, which of course implies very high temperatures, flow lines, further evidence of high temperature and surface melting, and micro impact craters, meaning each of the little micrometeorites has further craters little in it, showing that there were extremely small particles that were in this highly energized atmosphere under enormous energy conditions, right? So you have fusion crust, flow lines, micro-impact craters, all direct evidence for an extraterrestrial origin. One 140 micrometer long micrometeorite is 96% by weight iron and 4% by weight manganese. Another one is 71% iron and 29% titanium. Mammoth tusks contain rusty pits consistent with iron micrometeorites that were embedded and then rusted out. A sample of carbon glass in the black mat contains 62% carbon, 22% oxygen, 6% iron, 4% calcium, 4% silica, and 2% aluminum. At the Indian Creek Archaeological Site near Townsend, Montana, below the cultural layers and below the volcanic ash layer, now that's interesting, there's a volcanic ash layer there as well, there are individual glass bubbles about 1 millimeter in diameter that also have micro-meteorite craters. The size distribution of these micro craters resembles the size distribution of lunar craters, but at a vastly different scale. Beautiful example of scale invariance.
But they're bubbles? They're glass bubbles? Is that what he's saying? So
yeah, that's what he's called. That's the authors are referring to them as
wow.
Glass bubbles.
Wow.
So does that mean, like when you say scale invariance, I'm thinking that basically the moon is in a really slow, massive explosion?
No, Kyle. What we're saying here is that if you were to take and you were to, in other words, let's say we take a micro photograph, a scanning electron microscope photograph of these micro craters, and then we expand it to the size of the moon, what we're going to see is the same relative proportional relationships.
I got you. But I was thinking about it also in terms of time.
Yeah.
But maybe I'm just way off there.
There's a high degree of probability that that's the case. So,
touche.
I wonder, if they actually are bubbles. These little glass spheres are hollow on the inside. I wonder what they would find out by testing the gas that's inside them. That should contain exactly what was part of the impact energetic event.
This, what I'm reading from is from the abstract of the paper presented at this American Geophysical Union meeting. I don't actually have the paper.
Okay.
So I have no photographs. I would really love to have photographs of this.
Yeah.
Very possibly we could hunt some up, and I bet that's possible. Maybe even contacting the authors and seeing if they have.
I just think that would be really interesting. If they are actually enclosed spaces, that enclosure should contain the gas from the impact of the event, right? It's still in there.
Well, what they do say is that the carbon glass and the micrometeorites suggest a comet rather than a meteorite origin for the extraterrestrial material.
I wonder why that is. Composition.
Then also that year, 2008, M. Fayek, L. Anovitz, Vance Haynes again, evidence of impact material and the extinction of megafauna 12,900 years ago. This was presented at the American Geophysical Union fall meeting of 2008 that was held in December. Approximately 13,000 years ago, the landscape of North America was very different from what exists today. The Clovis people were hunting mammoths and other megafauna that roamed the land at the close of the Pleistocene. I don't know how many of them were actually, I'm sure some of them were hunting mammoths, but we'll come back to that when we talk about more about the mass extinction, because there's a lot of interesting material we haven't delved into yet with regards to the mass extinction and the relationship between the human inhabitants of North America and the megafauna. But evidence, they go on to say, evidence of these large mammals and the material remains of the Clovis inhabitants no longer appear in the geological or archaeological records after 12,900 years ago. This coincides with the onset of the Younger Dryas climatic event. The onset of the Younger Dryas appears to have been relatively abrupt, and it lasted for approximately 1,000 years. I think now we can say it really lasted more like 1,300 years, but that level of detail is not relevant to the point they're making here. There have been many theories put forth to explain the sudden changes in climate and human culture, and the Pleistocene megafauna extinction that appear to have coincided with the onset of the Younger Dryas climatic event. Few theories, however, have adequately explained the concurrence of all three events. Nevertheless, few researchers disagree that something major happened 12,900 years ago. And then they comment that in 2007, Firestone and others proposed that an extraterrestrial event caused the onset of Younger Dryas climatic event. They go on to say that skeptics argue that the ET extraterrestrial markers that have been described by Firestone and others are not sufficient evidence to prove the occurrence of an ET event, because evidence for an ET event, such as an impact crater, tektites, shocked quartz, high temperature minerals, and impact material are absent. Coming back, I think one of the things we'll conclude after this series of discussions about the Younger Dryas is looking at the matter of a crater, because that is the thing that the critics and the skeptics keep coming back to. Where's the crater? Where's the crater? Where's the crater? Yeah. We have a possible candidate in Greenland now, right?
Right.
But the dating is too broad to pinpoint it conclusively to the Younger Dryas.
Right. It's 12,000 to 3 million years old is what they said.
Right. So it could be,
yeah.
But as far as, the number of people that have over the months or so since that was revealed have asked me to comment on that, I have no comment other than the fact that it seems to be leaning towards a much younger age, but again, there's no conclusive evidence. And so I'm just taking a wait and see approach.
Right.
However, that doesn't mean it's not significant. Every time we discover a new crater, that's significant because it's adding to the census of impact events on Earth. And even if it was not Younger Dryas, but just, younger, say within the last few tens of thousands or hundreds of thousands of years, it's still part of the accumulating evidence that Earth is getting bombarded with far greater frequency than anybody was imagining a few decades ago.
Right. I mean, that puts two relatively large impacts on the Earth in the Pliocene. You got Behringer and now Hiawatha.
Pleistocene.
In the Pleistocene.
Yes.
Yeah. Well, if it's 3 million, possibly 3 million years old.
If it's 3 million, you're back in the Pliocene, yes.
Pliocene, yeah.
Right. So I would say that, within that frame of 13,000 to 3 million years, it's a greater probability of being Pleistocene, given that the transition is now dated to 2.5 to 2.6 million years ago.
Okay.
Right? That's an easy one to remember. Just keep that 2.6 in your mind, right?
Okay.
Because that's 1,000 precessional cycles.
Right.
That's right.
There we go.
Yeah. Or is it 100? It's 100.
100, yeah.
Yeah, it's 100. Yeah, 100. Exactly.
For a 19-mile wide crater, you're looking at potentially a mile plus wide object.
Yes.
To produce that.
Yes.
And if that's happening that recently, that is something really to be more commonly aware of, because that's about the same size as the Burkle crater in the Indian Ocean.
Right.
Yes. So I mean, even if it happened
5,000 years, so
yeah,
if we got two of those that large within the last 15,000 years, we really got to wake up fast.
Yeah.
And hell, even if it was 50,000 years, I mean,
exactly.
The evidence for frequent impacts is growing enormously, as is the number of sightings of near misses of extraterrestrial material. So
Brad, is that map that you have, is that the most current?
Well,
latest?
Because I doubt it. Because
actually, it's not.
They've got some new stuff from South Africa,
and
I don't think Syria is on here that you were mentioning. Maybe that's it at the very
that's
eastern point up there.
Yes,
but yeah, I think Randall's eventually going to get to it with this lecture today, or maybe next time. I just maybe got ahead of myself.
Well, Greenland's not in it, so
yeah.
Right.
Correct.
However, see, we'll talk about some findings in Greenland ice cores.
All right, good, because there's been some recent articles about those,
Right.
about the cores and the dramatic climate changes that they seem to show in the evidence.
Well, yeah, the 1993 Mayuski paper that I was just reading from was green. I think that was JISP 2. So that those cores in 1993, those cores had become available to workers and researchers, because they were the American team and the European team spent 5 years, actually not full 5 years, but because during the summer season extracting these 2 cores from the summit of the ice sheet. Somebody in one of the comments was saying that, well, there's if there was an impact there, what are we calling the impact in Greenland again? The Hiawatha Crater.
Hiawatha Crater,
yeah. In the Hiawatha Crater should have shown up. Well, in other words, through major deformation of the layers. Well, I mean, the Hiawatha is 1,000 miles or so away from the summit. It's a considerable distance. Far. Yeah, it's pretty far. So
there might be proxy material in the core.
Well, there is proxy material in the core.
Right, but it doesn't necessarily mean it would have shattered the ice all the way over there.
All the way over there, right.
Yeah.
Right. So here in this particular article that I'm reading from 2008, the skeptics are saying, well, where are the other things that the community of planetary geologists and scientists accept as diagnostic of hypervelocity impact? They name impact crater, tektites, shock quartz, and high temperature minerals, right? And they say that here at the Younger Dryas boundary, they're absent. So this is this team saying that. Now we get to this paper, they say, here we present evidence for the first time of chemical and textural. Here we present for the first time chemical and textural evidence of impact material from the Clovis Age Murray Springs black mat layer in Arizona. The impact material contains iron oxide spherules in a glassy iron silica matrix, which is one indicator of a possible meteorite impact. Chemical analysis of these spherules and the glassy matrices found in the particles from the larger size fractions are compared to the chemistry of carbonaceous chondrite meteorites, impact material associated with meteorite showers and meteorite craters, and tektites. The iron oxide rich glass matrix has an unusually high silica concentration consistent with the chemistry of impact material from meteorite showers. The chemistry of the matrix is not consistent with terrestrial minerals, but is similar to the composition of a eutectic point. I won't get into that because then I'd have to get off and explain it. But it basically points to when essentially a mineral would vaporize, we'll say that, okay, which is the eutectic point. And this is a silica dioxide, iron oxide system. The melting point there, the point, the takeaway from this is that the melting point of that chemical composition is about 1,500 degrees centigrade. So what they say is that in order to get this material that they're finding there, of this matrix material, it was presumably reconsolidated out of either vapor or liquid, would have required a melting point of approximately 1,500 degrees centigrade. And they then say such a high formation temperature is only consistent with impact or fulguritic conditions. However, the chemistry of the glassy matrices of the particles is vastly different from that of terrestrial material such as fulgurites. And a fulgurite, you know what a fulgurite is?
That sounds familiar.
lightning strike.
I think we might have read this before because Russ knew what the fulgurites were from. That eutectic and fulgurites. Yeah, that sounds.
I hope.
I think
I apologize if we've already gone over this, but it's really. Let me say this: we're trying to really learn this stuff here, and in any attempt to really digest and understand something, iteration, reiteration is extremely valuable. So if we overlap sometimes, no apologies, because the idea here is that we're hoping that the listeners really want to understand this, and we're learning as we go. We may have been studying this a long time, but good gosh, there's still so much more to know. So if sometimes we cover material that we've already covered, please bear with. Don't criticize it too much, because it really helps to ingrain the ideas in your head. Because remember the old saying, the devil is in the details, and we are trying to root out the devil here, aren't we?
We are.
I'm all for the repetition.
Repetition is good. Yes.
Yeah. Well, and if
up to a point.
If it took me that long to recognize it, then I need to be reading it again too. So
right. 1,500 degrees Celsius is 2,732 degrees Fahrenheit for all of us people that don't know what Celsius, don't know how to recognize.
Thank you for doing
Celsius.
that. I was actually going to ask you if you would do that.
All of us that use the real,
the actual
temperature measurements.
So
2732 degrees Fahrenheit. That's pretty hot.
That's warm.
Steel I think will melt lower than that. Pretty much lower than that. Yeah. So.
This is Kosmographia, the Randall Carlson Podcast.